Hello, good morning. I SEEMA GARG, Associate Professor in Chemistry, SPC Government College, Ajmer. Today, video 140. It is for BSc Part 1, Organic Chemistry, Paper 2, Unit 2, Aldehyde and Ketones. In continuation of name reaction, today we will discuss some more name reaction like Mirvain, Pondorf-Verley, MPV reduction, Clemenson reduction, Wolff-Christian reduction, and introduction to alpha beta unsaturated aldehyde and ketones. There is electrophilic and nucleophilic addition reactions. Mirvain-Pondorf-Verley reduction reaction. When aluminum isopropoxide is heated with carbonyl compound, keto or aldehyde, in presence of isopropyl alcohol, then carbonyl compound reduced to corresponding alcohol and acetone as byproduct. This reaction of reduction is known as Mirvain-Pondorf-Verley reaction. For example, if formaldehyde is reduced in this condition, that is aluminum isopropyl propoxide, then it will give methanol and acetone as a byproduct. If aldehyde is reduced, it will give primary alcohol and acetone. If ketone is reduced, it will give secondary alcohol and acetone. Mechanism. MPV reduction occurs by hydride ion transfer from aluminum isopropoxide to the carbonyl compound via cyclic transition state. See here how it is, this hydride is transferred to carbonyl carbon, and this is cyclic transition state, and then it will hydrolyze, and then it will give alcohol, corresponding alcohol, and this byproduct. This reaction is just opposite to Byers-Felizer oxidation. Reduction to hydrocarbons. There are two prominent methods for reducing carbonyl carbons to hydrocarbons. Clemenson's reduction reaction. It is an oldest method of reduction. Carbonyl compounds, ketones are treated with amalgamated zinc and concentrate HCl, that is ZnHe and concentrate HCl, to convert into corresponding hydrocarbons. Zinc amalgam, when ketone is treated with zinc amalgam in presence of concentrate HCl, it will give hydrocarbon. See here, if 1-phenyl hexanone is reduced in presence of zinc amalgam concentrate HCl, it will give 1-phenyl hexane. This method is not suitable for aldehyde to hydrocarbons because they get polymerized in the presence of concentrate HCl. However, benzaldehyde is not reactive towards concentrate HCl, hence it is reduced to toluene. Mechanism. See here how it is reduce ketone. This is zinc. It will give electrons, and then on protonation, it will give this product, and then further zinc is removed, zinc as a zinc acid, and it will give electrons to carbon, and further it will give zinc is removed and it will give its electrons, and finally it will give hydrocarbon. Next reduction reaction, Wolff-Christian reduction. Both aldehydes and ketones can be easily reduced by Wolff-Christian method, that is by heating a mixture of carbonyl compound with excess hydrogen and a strong base like KOH in diethyl glycol. Ketone, say, hydrogen in presence of a strong base, it will give hydrocarbon, and it will evolve nitrogen and water molecule mechanism. This hydrogen is added by removal of water molecule, and then hydroxy will give electrons. It will protonize, and finally, see here how this this proton is transferred to carbon, and it will evolve nitrogen. It will give anion. Then on protonation, it will give hydrocarbon. Now, alpha beta unsaturated ketones or aldehydes. This will gives electrophilic addition and nucleophilic addition reactions. Since they contain carbon-carbon double bond and carbonyl CO double bonds are present in conjugation, resonance takes place. See here. So here two types of functional group. One is unsaturated carbon-carbon double bond and second is carbon. As we know, this carbon-carbon double bond is normally it gives electrophilic addition reactions, and this carbonyl group will give nucleophilic addition reaction. And how these reactions are occur, let's see. Due to the resonance, this addition will change. Suppose if we are doing electrophilic addition reaction, it will give, see here. Here two types of this protonation. Protonation will add to here. Here two types of addition of proton is occur. If suppose it is added to this OH, it will give more stable positive charge carbon. Whereas when it is added to on this carbon, it will on protomerize, it will give less stable positive charge carbon. Then this nucleophile, how this nucleophile part, electrophile reagent is also contain weak nucleophile, and if suppose if it is added to this carbon, it will give unstable. If it is added to on this carbon, it will give stable enol form, and then it is on protomerization, it will give keto form. Thus, it may be concluded that addition of an HX reagent, unsymmetrical reagent, to an alpha beta unsaturated carbonyl compound takes place in such a manner that hydrogen gets attached to the alpha carbon and negative part, which is weak nucleophile group, gets attached to the beta carbon. See here, this is alpha carbon and beta carbon. So positive part is electrophile is added to this alpha carbon and negative part will attach to the beta carbon. So it is electrophilic addition to alpha beta unsaturated ketone. Nucleophilic addition reaction. How this nucleophile is added here. If suppose nucleophile is added, it is not formed this type of or it is unstable. When it is added to on this beta carbon, it will form, and on protonation, it will give us ketoenol form. So here, in electrophilic addition, the intermediate is a carbocation, whereas in nucleophilic addition, the intermediate is carbon anion or anion. This carbonyl group lowers the reactivity of carbon-carbon double bond towards electrophilic addition, but carbon-carbon double group, carbon-carbon double bond group increases the reactivity of carbonyl towards nucleophilic addition reaction. So thank you very much for today's lecture. In next lecture,